Solving systems of equations algebraically by substitution. Our objectives are that students will solve systems of equations using substitution. Steps for solving by substitution. First, you need to solve for at least one variable. Sometimes if you're lucky, they'll already give you a variable solved for, and then you know you're going to use substitution. Then you substitute that variable into the other equation, solve, substitute, solve, and then write your answer in an ordered pair. Remember, whenever we have a system, our answers are always going to be in an ordered pair, x, y. All right, let's take a look at the steps. Step number 1, solve for a variable. It can be either variable in either equation. Personally, I see the y sitting here all by himself. I'm going to solve for that y. So I bring this equation off to the side and I rewrite it. In order to solve for the y, I subtract the 6x to the other side. The 6x cancels out, and that gives me y is equal to negative 6x plus 11. So we just fulfilled step number 1. We solved for one of the variables. Step number 2, substitute that variable into the other equation. Well, here's where people get confused. I know that y equals negative 6x plus 11. So I'm going to take that negative 6x plus 11 and put it where the y is. Nothing else is changing. I rewrite the equation, 3x plus 2. Whenever I substitute, I always use parentheses. I write the negative 6x plus 11 that we got from the first equation, and I finish writing the second equation. Now I solve. So all I have are x's. If I have a y, then I know I screwed up. Distribute the 2. Gives me 3x. 2 times negative 6 is negative 12x. 2 times 11 is 22. Is equal to negative 5. Now I need to combine like terms. I have a 3x and a negative 12x. Also, I have the 22 and the negative 5. I'm going to go ahead and take care of those on the same step. In order to get the 22 to move to the right, I subtract 22 from both sides. The 22 cancels out. And I'm also going to combine like terms. 3x take away 12x gives me a negative 9x is equal to negative 27. Divide both sides by negative 9. And x is equal to positive 3. Now that I have a value for my x, I've completed step number 3, and I'm on to step number 4. Substitute that value into one of the equations. Choose whichever equation is easiest. Personally, I think it's easiest to substitute it back into the third equation. And you're saying, wait a second, there's only 2 equations. No, there's 3. I have the first equation, I have the second equation, and I have the third equation. I already solved for y. That's the variable I'm still missing. So I'm going to go ahead and substitute into that third equation. Y is equal to negative 6. My x value is 3 plus 11. So where I had a 3, I substituted it in where the x is. Now you get y is equal to negative 18 plus 11, which is equal to negative 7. Now remember what I told you. Your answer, your solution is always in an ordered pair. So make sure you write your answer in an ordered pair. X always goes first, 3, comma, negative 7. Then we box or circle our answer. For this problem, before I start my step number 1, I'm looking at these fractions. I don't like fractions, so I'm going to get rid of them. What is your common denominator? Well, the common denominator for this would be 6. In order to get 6, I'd have to multiply the left by 2 and the right by 3. Instead of getting a common denominator, I'm actually going to multiply everything by 6. What this is going to do is cancel everything out. And when I rewrite my equation, I'm left with half of 6 is 3x. 1/3 of 6 is 2y, and 6 times 6 is equal to 36. All I did here was simply get rid of the fractions so I don't have to deal with them. Now I can move on to step number 1. Step number 1 tells me to get one variable by itself. The very easiest variable to get by itself here is going to be my x. Why? Because all I have to do is add the y to the other side. So I add a y to both sides. That gives me x is equal to y plus 2. Now I have completed step number 1, where I solve for the one variable. Now I take that variable and I plug it into the other equation. So I know that the x is y plus 2, where I have the x, I'm going to type y plus 2. That gives me 3y plus 2 plus 2y is equal to 36. We need to distribute 3y plus 6 plus 2y is equal to 36. Now I have like terms that I can combine, the 3y and the 2y, and I have the 6 and the 36 that I'm going to move to the same side. Subtract 6 from both sides. Those cancel out. That leaves me with 3y plus 2y is 5y is equal to 30. The opposite of multiplying by 5 is to divide by 5. Y is equal to 6. Now that I've solved for y, I plug it back into one of the original equations. Now here I actually have 4 different equations I can use. One of the 2 on the top, the one on the right that I got rid of the fractions, and the one down here that I solved for x. The easiest one will be the one that I solved for x. That's going to give me x is equal to, my y value is 6, so I'm going to write 6 plus 2. 6 plus 2, x equals 8. I always write my answer as an ordered pair, 8, 6. Now this problem is nice because they've given us a few options. We can easily solve for the top y by subtracting the 7x over, or we can easily solve for the bottom y by dividing everything by 2. Personally, I want to divide everything by 2 because that's going to give me smaller numbers and make my life a little easier. Also notice, when you have a choice between substitution and elimination, if you have a problem that looks like this, where the x is already on the wrong side, then I strongly suggest using substitution. First thing I'm going to do is divide everything by 2. The 2's cancel out, giving me y is equal to 6 minus 7x. Now that I know what the y is, I can substitute it back into the other equation. That's going to give me 7x plus, what was my y? 6 minus 7x is equal to 6. So where the y was, I simply wrote what y equals, 6 minus 7x. Now, since there's nothing happening with the parentheses, we can just disappear them and combine like terms. Here I have 7x take away 7x. I also have the 6 that needs to move to the other side. So I subtract 6 from both sides. On the left-hand side, 6 take away 6 is 0. On the right-hand side, 6 take away 6 is 0. So I write a 0. Now I need to combine my like terms with the x's. 7x take away 7x is also 0. Now we've canceled out all of our variables. I have 2 options. It's either no solution or all real numbers. How do you know the difference? Is this a true statement? Does 0 equal 0? Well, yeah, of course it does. If that's a true statement and I have no variables, then my answer is infinitely many solutions. Some people will write it as all real numbers, which I personally like, but the book will usually use infinitely many solutions. All right, one more problem. Step 1, solve for a variable. If I look through this, there's one variable that stands out, easy to solve for, which will be this y right here. I can solve for that y by subtracting 6x from both sides. What that gives me is y is equal to negative 6x plus 23. Now that I know what y equals, I can simply substitute. Wherever I see a y, I can write negative 6x plus 23. What that gives me is 7x plus 5. Don't forget your parentheses. Then what is your y? negative 6x plus 23. And that's going to equal 23. So I simply replaced the y for the value of y. Now we're going to distribute. 5 times negative 6 is negative 30. Plus 5 times 23 is 115. And that's equal to 23. Now I'm going to combine like terms. I have a positive 7x and I have a negative 30x. I also need to move my 115 to the other side. So I subtract 115 from both sides. And that gives me negative 92 is equal to 7x take away 30x is 23x. That's negative. Now I can divide both sides by negative 23. Negative divided by negative cancels out, and 23 divided by 23 cancels out. Gives me x is equal to positive 4. Now I'm going to take that positive 4 and I'm going to substitute it in for the x. That gives me y is equal to negative 6. We always substitute using parentheses. 4 plus 23. Y is equal to negative 24 plus 23. Y is equal to negative 1. Remember to always write your answer as an ordered pair, x comma y, 4 comma negative 1.